The second kinematic equation relates the distance travelled, the velocity, the acceleration and the time. It can be written as the final position is equal to the initial position plus the initial velocity times the time plus half the acceleration times the time squared. So we write this down as y is equal to y subscript naught plus v subscript y naught t plus a half a subscript y t squared. So to derive this second kinematic equation, we actually need to use calculus. And so I'm not going to derive it in this video. Below this video and below the links to PhysClips, there's a short video which shows you how to derive this equation using calculus if you want to watch it. But let's have a look now at an example where we can use this equation to solve a problem. So the question is, a parachuter steps out of a plane 1.00 kilometers above the Earth. Neglecting air resistance, calculate the time it takes for the parachuter to fall to Earth. Okay, so it's probably not very realistic actually neglecting air resistance in this case, as air resistance is what slows the parachuter down and actually makes it safe for him to land. But we'll neglect it to make it easier. So the equation that we need to use is our second kinematic equation. Y is equal to y naught plus v naught y, so the initial velocity in the y direction times t, plus a half ay t squared. So let's write down everything we know. We know that the parachuter starts here with a y naught 1 kilometer above the surface of the Earth, so let's call that 1,000 meters, so that's y naught is 1,000. He ends up on the ground, so he ends up at y is equal to 0.00 meters. Now his initial velocity, he's stepping out of the plane, so we can assume that he's not moving vertically, and so the initial velocity in the y direction is equal to 0 meters per second, and he's accelerating due to gravity, so ay is equal to 9.80 meters per second, and we've been asked to find the time. Okay, so y, he ends up on the ground at 0. Y naught, he starts up in the air at 1,000. Vy naught is 0, so this term disappears because this is 0. And then we've got plus a half. Now ay, this is actually going downwards, so it's actually in the negative direction. So we should have actually written that as negative 9.80. So this is times minus 9.80 times t squared. So we need to rearrange this to get t. So let's move this over to the right hand side. So a half times 9.8 is 4.9, and when we move it over to this side, the minus sign disappears. So we've got 4.90 t squared is equal to 1,000, and so t squared is equal to 1,000 over 4.90, and solving this on the calculator, we get 204.08, and so t is equal to the square root of this. Now everything up here has been given to 3 significant figures, so let's give our answer to 3 significant figures. So it's 14.3 seconds, and that's to 3 significant figures.